Hi, I'm Chelsea, and today I'm going to show you a problem in which we use the chain rule. Now for this problem, it's actually a little more complicated, where rather than having just two functions composed together, we actually have a set of four functions. And this really demonstrates the power of the chain rule. So to begin, let's look at the function that we're interested in finding the derivative of. The function I've chosen is y equal to the natural log of the cosine of the quantity 3x to the fourth, the whole thing raised to the fifth. So to begin, I'm going to actually rewrite this just a little bit, which will more explicitly show what our four functions are. So I have the natural log, and I'm just changing my set of parentheses. The cosine of 3x to the fourth, that whole thing raised to the fifth. And the reason I wrote it this way was it clearly shows that the outside function is the natural log. As we go inward, we then have a quantity raised to the power of 5, that being the second function we're concerned about. Going inward a little further, we now have this cosine function, and the final, most inner function to worry about is this 3x to the fourth. Okay, so to begin and to organize myself, I'm going to write out each of those functions. So again, the outward function is f of x equal to natural log. Now I'm simply going to use just an x because that is the argument of my function. The natural log of x. The second one I'll call g is something raised to the fifth. The third function, h of x, is this cosine of x. And then finally I'll call the last function, j of x, is this 3x to the fourth. Okay. So clearly we have a composition of four functions. The derivative that we will substitute everything into, you recall we take the outside function, so we have f prime, and we keep everything nested inside. So that will be g of h of j of x. Multiplying that, we go inward one step, g prime of h of j of x. Going one step further, multiply that by h prime of j of x. And then finally we multiply by j prime of x. Okay, so a very, very long function. The more functions you have, the longer that this becomes. Clearly what we next need to do is find the derivatives of f, of g, of h, and j. So this is the reason I left a little room up here, is I'm just going to take some derivatives. So I'll get f prime of x is equal to the derivative of the natural log of x to be 1 over x. Derivative of g prime, so g prime of x is 5x to the fourth. H prime of x, the derivative of cosine of x, is a negative sine of x. And finally, the derivative of j, we get j prime of x to be 12x cubed, using the power rule. Alright, now that we have all our components set up, let's plug it into this nasty equation. So we'll get y prime equal to f prime of g of h of j of x. Okay, so 1 over g of h of j of x, which is actually just this thing right here. Okay, and if you wanted to, you could certainly just step back one thing at a time to figure out what this is. Again, it's always good to use lots of parentheses when using the chain rule. Okay, so I just substituted, again, what was in here just now into my derivative. We're going to multiply that by g prime of hj of x, so that'll be 5, some quantity raised to the 4th, so that'll be cosine of 3x to the 4th. Again, just substituting my j function into my h function wherever I have an x, and that's to the 4th, times a negative sine of j of x. J of x is 3x to the 4th. Okay, and finally I can just add in this j prime of x. So now the calculus is actually done, and it is time to do some simplification. The first thing that I notice is that I have a cosine of 3 times x to the 4th in a denominator, and that's raised to the 5th power, and over here I have it raised to the 4th. So that actually crosses out this entire quantity, and we're left with just 1 in the bottom. It doesn't look like anything else will cross out, so I'll just simply multiply 5 times 12 and put this all in the numerator. So 5 times 12 is 60. There's a negative sign from here. We still have this x cubed and the sine of 3x to the 4th. Okay, and all over what is left in our denominator, cosine of 3x to the 4th. Okay, and the last thing I noticed is that we have a sine of 3x to the 4th over a cosine of 3x to the 4th. So the same thing, again the same angle. So that sine over cosine is tangent. So we'll get a negative 60x cubed times the tangent of 3x to the 4th. And there is our final answer. So, negative 60x to the 3rd times the tangent of the quantity 3x to the 4th is the derivative of this function up here, our original function. And again, you can have many, many more functions composed in one another. It's just important that you write them all out and organize yourself. It's also always nice to write this step, which allows you to make sure that you have taken, you have each piece of the chain. And that's it. For more information, please visit our website at www.sandersontestprep.com. The link is in the description box below. Thank you.